Hey, grade 6, new video today. This one is going to move on in our study of geometry. It's called classifying polygons, and by the end, you'll be able to identify equilateral and regular polygons and also use Venn diagrams to classify polygons based on their properties. And when I say based on their properties, it just means like side length and angle or angle size and all that kind of stuff. Here's where we're going to start. We're going to start by just reviewing some stuff about Venn diagrams. Venn diagrams are usually you have 2 or 3 circles sometimes, generally 2 circles, and there's an overlap section where both of the criteria, so in this case this circle has all the dark shapes, this circle would have all the triangles, and then this overlap area would be all the dark triangles, and so that one would be C and then F. I like to start in the middle with the stuff that overlaps, and so C and F are both the dark triangles, and then for the rest of the dark shapes, that would be D. It's a shape, it's dark but it's not a triangle, and then over here all the triangles that are left, that's E. So I've got this one done, this one done, this one done, this one done, and then A and B are neither dark or triangles, and so I just put them here. So all the stuff kind of fits in one of these areas, okay? Now we can move that on to say, well, okay, here's some stuff that's polygons, and then all the stuff that's triangles, okay? And that fits all in the shapes. So again, I like to look at polygons that are triangles, and so C is going to fit in here. E is a polygon and a triangle, and F is a polygon and a triangle, okay? So D is a polygon but not a triangle. A is a polygon but not a triangle. And then B is not actually a polygon because polygons have to have straight sides, at least 3 sides, and they all have to be touching. And so B is a circle. Now what you might notice is that all the triangles are in the overlap section. Well, that's because all triangles are polygons. And so a more accurate diagram might look like this. This is technically also a Venn diagram, but all the triangles here, so again, that's C, E, and F, because they're both polygons and triangles, there will be nothing, like over here, there was nothing in just the triangle area. They all are polygons and are all triangles. And so B goes out here, and then A and D still fit in here. So that's a more accurate way to show a Venn diagram. Okay, and so where we go from there is we start trying to classify shapes, right? So we have to talk about how these two shapes are different. And so we can think of maybe, maybe the number of sides. We can say that they have a different number of sides, but they don't. They both have 5 sides. We can maybe say maybe the number of vertices, but they all have 5 vertices. We can maybe say the number of right angles, but they both have 2 right angles. And so there are ways that we can describe the shape to show that they're different. This shape has like a roof that's the same length both sides. This one's different. So these 2 side lengths are the same, whereas these 2 are different. Also, this pentagon has these 2 sides that are the same length, whereas this pentagon has side lengths that are different. Now, sometimes we need to know that sides are the same length without knowing the specific number, like the specific measurement. And so when we talk about that stuff, we can start using hash marks. And so if we want to show that these 2 sides that I just marked are the same length, we can use hash marks to show that they're the same length. And then once we get to a second pair, then we use 2 hash marks. Okay, so that shows us, even though we don't know the length of the sides, we know that the roof here, that roof looking piece, that those 2 lines are the same length and that these 2 sides are also the same length. Okay, now that brings us into a special kind of word which we've seen before, which is the word equilateral. We probably have seen it in terms of an equilateral triangle, but the word equilateral is basically made up of 2 different words. We have equa, and then we have the word lateral. And so equa as a prefix means equal, and then lateral just means sides. And so equilateral means equal sides. And so we can have, an equilateral rectangle, we can have an equilateral parallelogram, equilateral triangles, all these things that we've come across before. And what we see here is we have this equilateral shape. This is an equilateral rectangle, also known as a square. And so we can use hash marks. Now notice, because all four sides are the same length, then we can use the one hash mark to show that they're all the same length. Whereas when we look over at this rectangle, we see that these two sides are the same length, and then we see that these two sides are the same length. And so they have to be a little bit different, okay? Now, just like we can show side lengths that are the same, we can also use these marks that show that angles are equal. So for example, these two arcs mean that these two angles are equal, okay? And then again, these double arcs means that these two angles are equal. And so when we get onto the workbook practice, there's a question where all kinds of polygons have hash marks. And so we could also say, well, I know that these two sides are the same length, and then these two sides, sorry, the yellow doesn't show up real well, that these two sides are also the same length. And so you're going to see a question where you have all kinds of shapes that look like this that have arcs and dashes, and you have to sort of determine all of what's called the regular polygons. Now that's the next thing here, right? So shapes that have all sides the same length and all angles equal are called regular, okay? And so I'm just gonna, oh, I'm still in yellow, sorry. So if I have a very poorly drawn triangle, and I say, well, this side, and this side are all equal, and then that I said that this, and this angle are all equal. This is called an equilateral triangle. This is a regular polygon, okay? I could have a square, very poorly drawn square, where I know that all four sides are equal, and I also know that all four angles are equal. I could also have a regular pentagon, where all four sides are equal, and then all five sides are equal and all five angles are all equal. And then I could also have a regular hexagon, where all six sides are equal, despite my poorly drawn drawing, and then all six angles are equal. And that's also a thing that I could have. That drawing gets a bit confusing, but that's what we have. And so those are kind of the main basic regular polygons that we work with. You can have, a regular octagon if you want as well. But anyway, those are sort of the regular polygons that we work with, okay? And so, like before, we have this drawing where the outside square would be all polygons, and then the one circle would be equilateral, and then the second circle would be regular, except that if the shape is regular, it is by definition equilateral. And so all of the shapes would go in this middle section, and this outside area would be empty. And so a more accurate Venn diagram for that looks like this, where you have your polygons, and then you have your equilateral polygons that have, side lengths the same length, and then you have your regular polygons where side lengths and angles are equal. And so that really does explain sort of the whole lesson. I know it's an almost 9-minute video, but that's all I have for you today. And then the practice is on page 104 and 105. So thanks for listening, and work on your stuff, and have a great day.